Hi dear students. So today we will start our discussion of chapter 3, motion in a straight line. So that's the name of the chapter. So in this chapter we will deal the rectilinear motion. That means a motion in a straight line. So one dimensional motion that is, and their displacement, the path length, velocity, average velocity, the acceleration, and as well some kinematic equations are there for the one dimensional uniform motion. Then there are graphs, the relative velocity, all those things we will study in this chapter. So first of all, actually finding the wheels, that was one of the major revolution in the era of human life. That means the movement by finding the wheels, the movement became a little bit more faster, isn't it? So afterwards the movement became faster. That means the revolution in the human era also become accelerated or became faster. So motion is one of the important thing that you have to consider in our life. Suppose consider one day, if nothing can move, that means the human beings, the birds, animals all become like trees. They cannot move. They can just grow wherever they are. You just consider such a situation. So that's a tragic situation, no? Okay. So anyway, come to the chapter. So all things are in one way or other way moving, isn't it? Even our earth is revolving around the sun, isn't it? We are also moving along with that earth. But the frame of reference, a new term it is, it means we are inside the earth or we are on the earth, and that's why we cannot understand the motion of that earth around that sun. But suppose if we are on moon, and if you are watching the earth from moon, so we can see the movement of the earth. That is actually relativity. That whenever we are discussing the relative velocity, we will see these things more deeply. Okay. Actually, what is motion? Motion is change in position of an object with time. So with the respect to the time, if the position of the body is moving or changing, then we can say that body is in motion. And if that motion is in a straight line, okay, if it is in a straight line, then that is known as the rectilinear motion. Suppose consider an ant on one wire, and if the ant is moving on the wire, means if it is moving through the wire, then we can consider that one as a one dimensional or straight line motion. Okay. Where the path length, that means the length of the path through which that that object is moving, that should be considered as larger one compared to that of the size of the object. That means we are considering the object as a point object. Then our calculation or the understanding will be more easy. So that's why we are considering the path length always larger compared to that of the size of the object, and object will be considered as a point object. It's a point like object. Okay. And one more thing, if the motion is in a straight line, then it is also known as rectilinear motion. So motion in a straight line is also known as the rectilinear motion. And regarding, so if a body wants to move, then there should be an external force, a work should be done over there. So these are known as the kinematics of motion. We will discuss the kinematics of motion in the chapter 5, that is work energy, then force, work energy, all those these terms, these terms we will discuss in the coming chapter. Okay. Now come to the next one, that is the position, path length and displacement. So one of the basic and important topic in this chapter. Position, path length and displacement. Actually, suppose if you want to specify the position of an object, suppose now you and your friend went outside and you splitted away or splitted into two directions. After some time, if your friend is calling you, and then you should tell him that I'm just in front of the some XX, isn't it? Maybe a medical store, in front of the Ayurvedic medical store, otherwise in front of the cinema theater. You will just give the direction or give the position as compared to a non landmark, isn't it? Likewise only you can take the or tell him the position, otherwise the name of the place you will say. In same way, in the science or in the scientific way or in the scientific calculations, if we want to specify the position of an object, you should have some medical stores, or you should have some theaters or something you should have here. No, but here that are known as the coordinates, x, y, z coordinates. So these coordinates, with the help of the coordinates, you can determine the position of that object. Okay. So to specify the position, we need to use a reference point and set of axes. Okay. So you can compare with an example that I have given you earlier. In the same way, here also in this case, to specify the position, we need some reference points that are known as the coordinates and axes. This is x, y, z axis. I know you are familiar with the x, y, z axis. Okay, maybe at least x, y axis you know. One more axis you have to add up with that one, that is the z axis. Okay. So actually the axis will be drawn like this: x, y, and x and y are perpendicular to each other, and another axis which is actually projecting from the or projecting towards outside, okay, from the screen. So let us express that one like this. So x, y, and z, these are the axes. Now on the x there are a 1 centimeter scale. Suppose if we are taking 1 centimeter scale, after 1 centimeter, each 1 centimeter there will be divisions are given like this, and y also it will be given. A z axis also having the same divisions. And if you want, suppose a point is over here, okay, if you want to specify the position, so x, suppose here x is it as 1, it is 2, okay, so commonly here will be taken as x and this will be y, okay, this will be y. So the position of y is 2 and the position of x is also 2, okay, likewise 2, 2. So you have to express that one in like this, 2, 2, okay. So in such a way you are expressing the position of one object. That are regarding the axis and the coordinate system. Okay. So a rectangular coordinate system consisting of 3 mutually perpendicular axes labeled x, y, and z axis. The point of intersection of these three axes is called origin. So a rectangular section of axes are given, both three are perpendicular to each other, and at the point where they are joining is known as origin, and there the coordinate will be 0 0 in the case of x and y axis. If you are considering the z axis also, then one more 0 will be there. Likewise, you have to express the origin. Okay, if only x and y, or y and z, or z and x axis are considering, then 0 0 is enough for representing the origin. If three axes are combinedly, if you are considering, then it will be 0 0 0. You have to take like that. That is the origin. Okay, the point of intersection of the axis, and serves the reference point, the coordinate x, y, z of an object. Describe the position of the object with respect to the coordinate system. So as we have already discussed, suppose at a point 2, x is a point, if we are considering over here, okay, a point, and the corresponding x value if it is 4, and the corresponding y value if it is 3, then you have to consider that point, the position of the point as 4 comma 3 in the form of x, y, z. Z we are not considered over here. Suppose in a three-dimensional case, you have to consider the point, suppose in between x, y, z. Okay, that means on a air it is. It's not on a plane. So the three-dimensional we don't want to consider now. That is x, y, z planes are not necessary. Now for our need, only x, y plane is enough. Okay. So we will discuss along with the help of that x and y plane, and the corresponding value on x-axis if it is 4, and the corresponding value on y-axis if it is 3. The position of that point will be given as 4 comma 3 in a bracket. Okay, such a way we are representing the position of an object. Okay, regarding that coordinate system. Now, to measure time, we position a clock in this system. This coordinate system along with the clock constitute a frame of reference. Suppose x1, y1 was the position of the object at the beginning. Okay. Now we have to consider the time, that is after a time t, the position of the object became, or the position of the object became x2, y2. Okay, x1, y1 was the first initial position, or 4 5, likewise you can say 4 or 5, so 4 comma 5, that is the 4 is the value on x-axis and 5 is the value on y-axis, and after some time it changed to 10 6. This 10 is the value on x-axis and 6 is the value of y-axis. So time taken for this travel is, okay, 10 minutes or 10 seconds. 10 seconds you can take. Then you have to find the velocity likewise. So positions you are having, the time you are having, then you have to find out the velocity, acceleration, all those things. If you are having the difference between the positions and the time taken for that movement, then you can find easily the velocity and the acceleration. The equations to find out, or the way to find out the velocity and acceleration, we will we are going to see that one. Okay. If one or more coordinates of an object change with time, we say that object is in motion. Otherwise, the object is said to be at rest with respect to this frame of reference. Okay, that means if the coordinate value is changing, suppose the initial the coordinate was 10 and 8, okay, one or more, even if the position on the or the change, even if the change of the coordinate value in one axis is happening, then also we can say that body is in motion. That is the x value the beginning 10 5 was 10 was the x value and y value was 5. 10 5 was there. Okay, 10 5 was there, and after some time the value become 10 8. Okay, the time taken as 2 seconds. After 2 seconds the position changed to 10 8, where we can see the x coordinate is remain same, but the y coordinate is changed from 5 to 8. Then also we have to consider that body is in motion, and actually it is in the only the y coordinate is changed. Okay, then also that body is in motion with respect to the time. Okay, is this much clear? Now let us come to the path length. The total distance traveled by a body during its motion is known as the path length. So a total distance traveled by the body during its motion. Now let us consider the origin O. Actually we are dealing with the linear or the rectilinear motion. For representing the rectilinear motion, one axis is more than enough. Okay, so here we have considered only the x axis. Okay, x axis we have considered, and the values. A body is starting. Consider a body is starting. Now we are going to see the path length, how to represent the path length. Now a body is starting its journey from the origin, that is the 0. So it is moved till this 160. Okay, now in this case the path length, here the unit is given in meter, so the path length of the traveling of the body will be 160. So it begin from 0, then 40, then 80, 120 and 160. So it's moved a total of 160 meters, so the path length will be 160. Now again, if it is continuously moving till 400, that means from O till 400 if it is moved, then the path length will be 400. Okay, path length will be 400. Suppose if it is started moving back and if it reached 200, then that means the total path traveled by the body will become, that means from 0 to 400 and from 400 to 200. That means the total path length will be 400 plus 200, isn't it? 200. That means the total path length will become 600. Okay, so the total distance traveled by the body is known as the path length. Okay, I think now it is clear, the path length. Even if that in the second case you can see that the body started from O, it reached 400 meters and it is moved back again, or coming back to the initial point, but there it is traveling at 200 meters. The 400 to 200, it means the total 200 meters. So the total path traveled by the body is 400 plus 200, that is total 600. Suppose if the body is traveling from here, from beginning it from O, reached 400 and it is moved back till 320, so then the total path length will be here 40, 80, 120, 160, likewise 320, 400. 400 afterwards it is moving back, 400 plus 400 and again 400 to 360, the position 360, that means the difference it is 40, isn't it? So 440 and 320, there it will be 480. Are you getting or not? So the total path length it is 400 plus 80, so will be 480 meters. That will be the total path length. Okay, So can we go to the next topic? That is the displacement. Let x1 and x2 be the position of an object at a time t1 and t2. So x1 is the position of the object at t1 and x2 is the position of that object at t2. Then its displacement denoted by delta x. This is a Greek alphabet and it is known as the delta. Okay, delta x in time. Delta t is equal to t2 minus t1. So the change in time is t2 minus t1. T1 is the initial time, t2 is the final time. Then the displacement will be given by x2 minus x1. So it means x1 is the position at the time t1 and x2 is the position of the at the time t2. Okay, so that is known as displacement. Okay, and if x2 greater than x1, delta x is positive, and if x2 less than x1, delta x is negative. Okay, remember this one. If the final position is greater than initial position, then delta x should be the change in position, or the displacement will be considered as positive. And if x2 less than x1, that means the final position is lesser than the initial position, then delta x is negative. That is, the displacement is negative. But if you are comparing this one with the path length, you know that the path length can only be positive. Okay, there is no negative signs for the path length. That means path length is a scalar quantity. The scalar quantity means there is no direction. We are not having any direction, only the magnitude, only the value, the quantity only you have to measure. There is no directions in x direction, y direction, north direction, south direction. There will be no directions. Okay, only the magnitude. Likewise, you are counting the number of some pebble. Suppose if you are counting the number of some pebble or stone, do it have some directions, that number? No. The same way, same method. Okay, so here you have to consider only the number, not the direction. But in the case of in the path length, but in the case of the displacement, you have to consider the direction. That means it is a vector quantity. Vector quantity has both magnitude and a direction. That is why if the final position is greater than the initial position, then the delta x, the displacement, is in positive. And if the x2 is less than x1, then delta x is in negative. That means the positive and negative are indicating the direction. Negative means to this direction, to the left direction. Positive means to the right direction. Okay, displacement has both magnitude and direction. Such quantities are represented by vectors. If a quantity has both magnitude and direction, then such quantities are known as vectors. Okay, now let us come to the displacement. Suppose if a body is moving from O, initial, that is the origin, to 260. Okay, so this is the x1 at a time t1, and this is the x2 at a time t2. Okay, that is, one is 280 and another one is 0. So during the time interval t2 minus t1, the displacement happened to the body is taken as 240 minus 0. That is 240 minus 0, x2 minus x1, isn't it, which will be is equal to 240 meters. Here the magnitude of path length and magnitude of displacement will both are equal. The path length is the total displacement happened, that is here 0 to 240. Okay, 0 to 240, that means 240 meters, and displacement is x2 minus x1, that is also 240 meters. Now come to another condition, that is if the body started its motion from origin till 400 meters and then it started returning back till 160. Okay, till 160. In this case, this is x1 t1, that is the origin, and 160 is the x2 t2. The displacement will be is equal to x2 minus x1. Here x2 value is 160 minus 0, that is 160 meters. This is the displacement. Okay, displacement. 160 meters. Now let us go for the path length. How will be the path length, or the total distance traveled will be is equal to how much? That you have to find. So 0, its journey from 0 till 400, the total path traveled is 400 meters, and again 400 to 360, 440 will be the total, 480, then at 280, if we are considering 400, 440, 480, 520, then 560, and at 200 it will be 600, and at 160 it will be 640. So where the total path length traveled by the body will become 640 meters, but at that time there is the path length. Okay, path length, but at that time displacement was equal to x2 minus x1, that is 160 minus 0, which will be is equal to 160 meters. Okay, so path length is the total distance traveled, and the displacement is the change in the position of the body in the initial and final. Change in the initial and final position of the body. Here the body reached 160 meters away from the initial position. That means its displacement it is 160 only. Even if it path through the entire entire large path it is moved, but still the displacement it is returned back, and the displacement will become only 160 meters. But at that time the path length is equal to 640 meters. Now I think you understood the difference between the path length and displacement. So the magnitude of the displacement for a course of motion may be 0, but the corresponding path length is not 0. Yes, that means suppose if the body is starting from the origin and it is reaching 400 meters and it is returning back to the origin. Now the x2 and x1 both are origin only, 0 only. So 0 minus 0 will be 0. That is the displacement happened to the body due to the motion is 0 only, because it is returned back to the initial position. All the way it's moved and it is returned back the initial position only. So the displacement is 0 only. That means suppose if you are starting a journey from the RTO circle and you have moved or you have passed through the entire roads, entire Bhuj city, suppose if you have covered, and if you are coming back to the RTO circle itself, That means the displacement which is happened to you is 0 only, but the path length will be in this come to this condition. Here the path length which is traveled by the body will be 0 to 400, again 400 to 0, so total it will be 800 meters. 800 meters path length is there, but still the body is in the initial position only, so the displacement will be 0. The path length cannot be 0, but the displacement can be 0 also. Okay. If an object moving along a straight line covers equal distance in equal interval of time, it is said to be in uniform motion along a straight line. Okay, regarding uniform motion. So in this chapter we will be considering the uniform motion in a straight line. So what is uniform motion? That means suppose if the displacement happened, or the distance traveled is directly proportional to the interval of time, then that is known as the straight uniform motion. Means so in 1 second, if the displacement happened is 1 meter, and in the next second, that is the 2 second, the displacement will be 2 meters. In the third second it is 3 meters. Okay, then it is known as, if you can say that one as the body is in uniform motion. But at that time, if the 1 second, if the displacement is 1 meter, and the second if it is become 3 meters, and again at the third second if it is 4 meters, that means the displacement happened to the body is not uniform. Okay, are you getting or not? That means equal interval of times should be covered in equal interval of, equal interval of distance should be covered in equal intervals of time. Then that is known as the body, that means that is known as the body is in uniform motion. Okay, so I think you are clear with this much things. The graph we will discuss later. Okay, so thank you. Study all those things thoroughly. Actually, this is one of the important chapter. Okay, read the textbook first of all.